Hi guys, welcome back to the think class of operating system concepts. And right now we are going to discuss something more about operating system classification and structures. Okay, so let's begin the session. And we are in session number 4 of operating system classification and structures. So beginning with the question, what are the common system components then? The system components consist of, in a computer system, we can see such and such computer system components, and those are process management, main memory management, secondary storage management, I/O system management, file management, protection system, networking, and command interpreter system. We will be dealing with each components part by part. So now the second query is about what is process. A process is a program in execution, something that is a program in execution. So it's a program which is in a running phase. A process needs certain resources like CPU time, memory, files, and I/O devices to accomplish its task. And this is a brief description about what is a process. And now, who is responsible for managing the process then? Who is responsible for process management then? The operating system as a whole is responsible for managing the process. And what it does, it does process management performing following activities. What it does is just creates the process. In the phase of process management, it creates the process, it deletes the process, or it suspends the process, or it resumes the process. So it's like it does following kind of activities with the process: creating, deleting, suspending the process, resuming the process. And lastly, and not the least, it also provides some kind of mechanism for the process, like process synchronization and process communication. So now let's jump to the next question. So what kind of activities are performed by operating system for main memory management then? It performs following tasks. It keeps track of which part of memory you are currently using and by whom. So tracking who is using the memory and which part of memory is being used. So this kind of tracking is done by the operating system while he tries to while the operating system tries to manage the main memory. And then it also decides which process to load when memory space becomes available. So whenever there is a free memory space, when the memory space becomes free, then which process should be loaded in the memory. So it decides, and that is the operating system. And allocating and deallocating the memory space are also needed, and this is done by the operating system. And these are the functions that is done by operating system to manage main memory. Now next, why we should use secondary storage then? In the secondary storage, so what is the particular purpose of using the secondary storage? Since you guys already know that the main memory which we are using is very volatile. device. That means it is easily it's filled up, like it's very small memory is available, like it's not a huge space. There is some limited space available in the main memory. Only limited data and limited programs can be permanently stored in the main memory, right? So considering this perspective, we use this secondary storage, and we use this to back up the main memory. It acts as like a backup storage, so that any extra items, like any extra data or any extra files, directories, anything, programs, can be stored here, as a reserve, acts as a reservoir. So what does operating system do to handle this kind of secondary storage, or how does operating system manage this secondary storage devices then? This performs two following tasks while handling the secondary storage. It frees the space, it allocates the storage, and it performs some kind of tick scheduling. So it schedules, like, right? So this kind of activity is done to manage the secondary storage. And the next, what about how the operating system manage the input and output system then? We can see that the operating system has following tools to manage the I/O system, input and output system, and they are the buffer caching system, and also the device driver interface, and also the driver for specific hardware devices. So I/O is managed all by these kind of drivers and buffer caching system. Because as far as you already know that each I/O devices has their own local buffer, and each I/O devices are managed by the device driver. So these are the only tools that manage the I/O system. Extending our concept. So what is the file then? It is just a collection of related information defined by its creator. So file can be something like a program or a data. A program that you run is also a file, whereas any data that you store is also a file. So everything is stored in a file. In operating system, everything is a file. Programs, so all that, the software that you run is also a file. Anything that runs is stored in a file, in operating system. So how the operating system manages this kind of file then? It does following activities to manage the file. First, it as you see above, like while managing memory or some other thing, like process management, it created, deleted, suspended, it resumed. So something like this. Also for file, it starts creating and deleting the file. It does something like this to manage the file. And also the directory can also be created and deleted. Directory is something that is a collection of a file, is a directory. Whereas something like primitive support of primitives for manipulating files and directory is also done here. So mapping the file to any kind of storage, secondary storage devices is also done here. Backing up the file, So reserving it for some future purposes in a non-volatile storage is also done here. Non-volatile means permanent storage, so you can store it permanently. That's the idea. So now jumping on the next question, like how does the operating system assures the protection of the system then? Operating system performs the following task, okay, to assure the system is very protected. Okay, and what it does is it allocates the resources to multiple users or multiple jobs running at the same time. It also controls the access to the system and user resources by distinguishing between the authorized and the unauthorized user. Okay, so what it does is it start distinguishing between the who is using the system resources, okay, and what kind of resources he is using. So it also start keeping track of all the records, okay, what is the user using, okay, and what kind of computer resources is he using and when it is using. So everything, the information is, everything is tracked, okay, and this is done just for account billing or for some certain kind of statistics that the operating system performs. And also you can say that it also specifies the control to be imposed on a program, processes or users. And lastly, it also provides a means of enforcement to ensure that all the accessed system resources is within control. Okay, there is no misuse of the system resources or something like this. Okay, what is networking then? Networking is something like a distributed systems, as we have discussed before, right? Distributed systems means systems with many processor, okay, interconnected by a communication network, and they have their own local memory. They do not share their memory, okay, and they do not share their clock. They have their own local memory. So this is networking. This is all done. Operating system also helps for smooth networking. That means increasing the computational speed, increase data availability, okay, and enhance reliability. So this kind of assurance, okay, operating system assures that the networking among this kind of distributed systems is all performed well. Okay, so among all the components, the last components of a system components we can see is the command interpreter system. And so in this command interpreter system, what is this? Okay, before going to the command interpreter system, there are so many commands that for the idea you guys have to know that there are so many commands, okay, given to the operating system by control statements. Okay, this kind of commands, okay, they can do or they can perform many kind of activities. These normal commands, they're like the activities of process creation, management, IO handling, secondary storage management, main memory management, files, system access, system protection, networking. Everything can be done just by this simple command, okay, which is given by control statements to a operating system. So and this is all about the command interpreter system, and the tools that read and interpret this kind of command, okay, and this kind of control statements are called control card interpreter, or they can also be called like command inline interpreter or cell. In most used is the cell in Unix. Okay, what are system calls then? System calls are something like it acts as an interface between running program and the operating system. Okay, so all the running program which the user can access can directly communicate with the operating system, and this is all done is possible only through system calls. Okay, so how do we pass the parameters from by this system call to the operating system then? Right, so passing the parameters are all done in registers, and how it is done is like you store the parameters in the table memory first, and the table address is passed as a parameter in a register. Firstly, what we do is you just store the parameters in the table memory, and what you just do is you just give the table address on which the parameters are stored, okay, in a register. So this is just done like this, and the action that is performed is push and pop, like stack. Okay, we use the stack memory and like push is performed by program to store the parameters. So any programs just push the parameters onto the stack, whereas pop is performed by the operating system to just use the parameter that is just passed by the user program. So just it works just like this, and the parameter is passed, okay, while you communicate with the operating system, while the user programs communicate with the operating system using the system calls. The information or the data is stored, and the data means the parameters are all passed through a special method used in stack, okay, stack memory access. So something like this. Okay, what are system programs then? Operating system is defined by system programs, not actually by system calls. So you have to remember this concept about system programs. This provides a suitable environment for program development and execution. Okay, they are divided into so many things. They are divided into, you can see here, file manipulation, status information, file modification, programming language support, program loading and execution, communication, application programs. Okay, so it's just system programs is just providing you some kind of suitable environment for program development and execution. So file modification, programming like application programs. So all the application programs you can see here, okay, Google Chrome, you can say that this is like the terminal. Okay, you can see anything like for example all kind of application. Okay, if you check out, these are all the environment that is providing you some kind of platform, okay, for program development and execution. Okay, now giving you the idea, okay, about the simplest operating system model, and that is based on the principle of simple approach, and this one is called MS-DOS system structure. And the approach is very simple and written to provide the most functionality in the least space. So the idea is very less space, but you can use you have a high functionality. It's trying to provide a very high functionality using a very least space. So this kind of programming principle was used in MS-DOS system. That was the earliest version of operating system. And but the thing was like it was not divided into modules. So interface and level of functionality were not separated. So this was the problems that was encountered here in MS-DOS system. It was simple. We used the simple approach using the least space, but the problem was that it was all the functionality were not separated, so every functionality was just interrelated, and even the interface was also not separated. So what is the Unix system? There is the second most important operating system that was developed by the Unix, and that was developed by using the simple approach principle, was the Unix operating system. Okay, and the Unix operating system consists of two separate parts, that is the system part, the system programs part, and the kernel part. So you can check out the whole Unix system structure here. Okay, you can see it consists of the user, and the second, like, it consists of the shell and commands, and this shell and commands consist of compilers, interpreters, and system libraries, whereas it also consists of the kernel interface, that is the system call. Okay, and signal terminal, disk tape, device drivers, everything, file system, CPU scheduling, memory paging, everything is also present here. Then you can see a different level, that is a hardware kernel interface level. Okay, and then like terminal controller, disk controller, memory controller level. So this is overall the brief idea of how the Unix system is separated. Okay, it's how the layers are separated. Okay, now what are the system structures which are based on the layer approach then? What is layer approach? In the layer approach, in this principle of layered approach, how we develop our operating system is like the operating system is divided into number of layers. So each layers are built on top of lower layer. Okay, so on the basis of lower layer, you start building another layer on top of it. So on the second top of it, like you keep on building more and more. It's just like you start building a base, and on top of the base you start building more, and you keep on adding. Okay, you keep on adding, so it can reach to the highest layer, that is the layer n, and starts from the bottom layer, that is layer 0. Okay, the layer are selected as such that each uses functions. Okay, operation. Functions, operation, services of only lower level layers. Okay, so only each uses only the service of lower level layer. That means like hardware. CPU only uses hardware. The service is provided by the hardware, and the memory uses the service provided by the CPU, whereas operating console device drivers use the services provided by memory, whereas buffering input and output uses the service provided by operator console device, and user programs perform like uses the service provided by buffering for input and output. So it's like just like this. Something like first principle was like something is like on the basis of the lower layer, you start building the upper layer. You keep on building, and then the services provided by the lower level can only be used by the upper, just one step upper layer. So just the principle is this one. Okay, now going on to the next concept about what is virtual machine. Virtual machines are those which provides an interface, okay, identical to the underlying bare hardware. That means it treats hardware and the operating system kernel as though that they were all hardware. Okay, so it it treats hardware and the operating system kernel as a hardware itself. So that's why it creates a virtual machine. Virtual means invisible machine, so it creates something like an invisible machine. Okay, it's like something that is as a whole, it's like a hardware. So thus it creates, the operating system creates the illusion of multiple processes. Okay, so multiple processes are like, it seems that the multiple processes trying to run and access the hardware system. And like also each executing on its own processor with its own virtual memory. So that means multiple processes are created, okay, and it acts as if like we have multiple processors, okay, and each processors are using their own separate identical processors to execute their own task. Okay, lastly, what is the microkernel then? Microkernel is something, it's a near minimum amount of software that can provide the mechanism near to implementing an operating system. That means a very minimum amount of software that is required, okay, just to use the mechanism, okay, to implement the operating system. So this kind of mechanism is the microkernel. This kind of minimum amount of software is microkernel. So it's like very minimum amount of kernel, something like that. This mechanism include low level address space management, thread management, and inter-process communication. So all these things is done here. Okay, and for your idea, microkernel can also be taken. It also consists of the block that is a wake up driver, okay, and this wake up driver wakes up the device driver, whereas it also consists of the interrupt handler, and the interrupt handles the IO completion error and interrupt. So it does just work like that. Okay, lastly, in this topic of operating system classification and structure, okay, what is the most important point for the developers, okay, for who want to design the operating system, is you have to design the operating system considering two basic concepts, that is user goals, okay, and the system goal. In the user goal, the designer must understand is that operating system must be very convenient to use and easy to learn, reliable, safe, and fast. This is the very important concept that every designer must understand while designing a user operating system. Whereas the system goal is operating system must be very easy to design, implement, and maintain, as well as flexible, reliable, error-free, and efficient. So this is the key concept while you are trying to implement do the system design and implement. Okay, this was all about the topic, the key concept about the topic, operating system classification and structures. So we'll go to the next, okay, we'll deal much about the upcoming topics in the next session, and I hope I answered all the required questions about these system structures and some ideas, okay, that might help you guys to understand and the basic concept of operating system. Okay, thank you.